modeling techniques. Okay, in the last few classes we have discussed about the state model, and in the coming classes we would be studying about more models in details. So today we'll be starting with the object model. About the object and the classes and their representation we have already discussed in the previous classes. Now just we'll have an introduction about object modeling, what are objects and attributes, what is the relation between them. That all thing we would be seeing in detail, and in the next class we will learn how we can draw this model, or how we can draw an object, a model, how we can show the different relations between them, and draw them in a pictorial form. Okay, so that we will be doing. So I'll just share my screen. Okay, so today we'll be discussing about introduction to the object model. So we know that objects, when a class consists of objects, and objects have some common properties. Based on them they have some class, or we know that object is an instance of class which is derived from it, and we can call it at several places wherever we need them. Okay, so for that purpose objects are being defined. So let's see what is object modeling and how does it helps in making our design representation of any developing phase, any software developing phase successfully. So object-oriented design modeling is our subject. So what is object-oriented analysis, or what is object modeling? Okay, so we can say that it is an approach which is used to understand the behavior of the objects and where all it can be used. Okay, if an object has been called, or if an object has been created, so what was the purpose of creating that particular object, where was it called, and where in new places in the program it can be called again and again. Now if we are calling an object, so it depends, are we using it for the new purpose, or we are calling it for the same work. Okay, so if they can be reused or adapted for new uses, define new or modified objects. Okay, so when this model would help us to understand where all an object can be called, how it can be used in different places, and if we have declared a single object, how it can be recalled or reused. That is the main purpose of this particular object model. Now, in this, objects are usually combined. Okay, so whenever we declare an instance of a class, we can have some properties, or it depicts a model of that particular class, which may have its own modified properties also, or it can have a properties of a class which were defined earlier. So it states that it would be representing that model. This diagram would be representing the relation between all those objects which we have declared. Now, few objects would be which would have used once, few objects would be which would have used multiple times, and few objects would be that have been modified according to their need, according to their requirement or demand in the business, or according to their demand in the various application usages. So that is object oriented analysis. That is how it is being done. Now, object modeling. We can call object modeling as a technique which would help us to identify the object which are required to complete a system or a project, or which would be required in an environment, so that we can create that working thing completely and observe its behavior. Okay, so we can say that identifying objects within the system environment and the relation between those objects, how those objects would be related with each other, how they would be behaving, that we would be doing in object modeling. Now, what exactly it does? The modeling technique describes the use of methodologies and diagrammatic notations that are completely different from the ones used for data modeling and processing modeling. Okay, so when will we studying about this DFT data flow diagram, and that will see what is data modeling and process modeling. Okay, when we were studying about the functional modeling, and we that also we saw the how notations were used, how they were having transactions, how they were having connections, relations between each notation. The same way, in the object model, we would learn how objects which are being derived or which belongs to a particular class or which falls under a particular cluster or groups, how they are being connected with each other, how they are interlinked. That would be explained here, and we would also study that how they are working, how they would help in making our project complete, how they are behaving, how they are acting. Okay, so what would be the notation? How I would represent an object in an object modeling diagram? How object of a one class would look different from the object of another class? If objects from two classes are related with each other, if they are interacting with each other, how they would be interacting, what would be their behavior, what would be their word of action. Okay, that all things would be defined in object modeling. So we can say that object is an instance of class which has some behavior that can be called uh, depending upon the requirement, that can be used, modified, that can be declared. Okay, and how those objects are related, how those objects are acting, how the data flow among that objects are going, that would be represented in object modeling. Now, next, see, we'll study about object and attributes. Okay, now attributes, we know that the data that represent characteristics of interest about an object, means we can say data which shows the characteristics of an object. Okay, now how what are these objects and attributes in an object modeling? I'm sorry for the Okay, so objects can be defined as something that is capable of being seen, touched, or otherwise sensed. Okay, and about which users store data and associate behavior. So if we want to define an object in an object modeling or in real life also, we'll be talking about classes and objects. So we can say that it can be a thing which can be seen by our eyes. Okay, we can touch it, otherwise we can sense it, or we can store some data, or it would have some behavior. So that would be object. Now, we can, if we want to define object or take an example, we can take person, place, thing, or event. If we'll be talking about employer, can be an object, customer, instructor, student, warehouse, office building, room, product, vehicle, computer, video tape. Okay, so these all can be defined in objects which would have some properties. They can be seen, they can be touched, they can have some information within it. Okay, so this can be seen or can be declared as objects. Now, about attributes, the data that represent characteristic of an object is usually defined as attribute. So, attribute can be defined as an data which represents the behavior of the object. Now, there are several concepts that object oriented analysis is based on. So the concept that is based on is sometimes these concepts required a totally new way of thinking about systems, a developing process. It also represent challenges which are involved in the developing phase by the developers. Okay, so these all things are initially viewed. These all things are initially understood when we design object modeling and we talk about the interaction between them, or we talk about the communication between them taking place. Now, object oriented approaches to systems development are concerned with identifying attribute factors of interest regarding an object. Now, it is important to note that with advances in technology, attributes have evolved in include more than simple data characteristics. As the things are getting developed day by day, we can see that object features are getting modified. They are being done in a better way. Okay, so that can be seen. Now, today, objects may include newer attribute types such as bitmap or picture sound or even video. Examples of objects and their attributes that exist. If we'll be talking about a classroom, if we'll be talking about a staff room or college, if simple objects we'll be talking about simple. If it was a physical environment, we would see that objects would be a pen which you would be using, color of ink would be its attribute. Okay, so these are would be the few examples of objects and the attributes. Objects which have some properties, okay, which can be seen, sensed, or which can be modified. Okay, its properties can be modified according to the needs, and attribute would can be called as in data or information which tells about its characteristics. Next, object and object instances. Okay, what are these objects and what are these object instances? So, object instance, each specific person, place, thing, or event, as well as the value for the attributes of the object, can be defined as object instances. Okay, if we have defined if a class has object. Okay, so if we are talking about person, so each person, okay, maybe his name, a place, thing, or event, as well as the values of the attributes of that particular object would be depicted or would be defined as object instances. Now, this depicts the representation of object instances. So when we would be studying about its representation, so we'll see that how it works. Now, an object is usually represented using a rectangle. Okay, so we can say that whenever we'll be drawing the object model, so we can say that using a rectangle, we can represent how object looks. Now, the name of the object instance and its classification are underlined and appeared at the top of the symbol. This I'll show you tomorrow when we'll be drawing this object modeling. We'll be seeing certain situations or cases, and based on that we would draw an object and object instances. Now, the attribute values for the object instance are optionally recorded within the symbol and are represented from the object name with a line. Okay. Now, what about the attributes? In a diagram, how these attributes are represented. So, the attribute values for the object instance are optionally recorded within the symbol which we have here, and are separated from the object name with a line. Okay, with the slash it would be separated. So when we would be writing about object rain in the rectangle box on the top, so it would be separated from it by a single line. Now the name of an object instance is the value of the attribute that uniquely identifies it. So we can say that if we are talking about the name of the object, okay, if you are talking about the name of an object instance and its value of the attribute that uniquely identifies, so we can say that it will show what is the value, what is the information stored in the object, means value of the attribute that uniquely identifies it. Now the attribute, now let's talk about the customer number whose value is something, maybe 1, 2, 3, 4. Okay, which would help us to uniquely identify the customer with the help of that customer number, that instance of a customer. And the name of the object instance would help us in the classification of that particular customer, means to identify the behavior of that particular customer. Okay. Now, if we'll be talking about the instances, if we'll be talking about the instances, we can see that how these value would help. Okay, now let's see how these things would help, means what would be the behavior, how we can combine them, how we can combine these objects in a single thing. Let's see that. So we have the next thing is behavior and encapsulation. Okay, we are talking about the behavior, how these objects would behave when they are arranged, interlinked with each other, means they are having some properties, how they would be behaving. Okay, so we'll see that how these would help, how they would act. So let's see the behavior and the encapsulation in object modeling. So behavior, the set of things that the object can do that correspond to functions. Okay, that act on the object's data, that is attributes in object oriented circles and objects. Behavior is commonly referred to as method, operation, or service. Okay, that means let's see, we are talking about the behavior of an object. So behavior would be set of things, means that would be related with that object. That would be object data, that would be object behavior, that would be object function, that would be object value. Okay, and in object oriented circles and object behavior, so in the diagram the object behavior, what is the behavior of that particular object, would be always represented with the help of a circle, which is usually referred to as method. We call that circle as method also, behavior also, or service also. Now let's talk about the encapsulation, how encapsulation would help in drawing this particular object model. Okay, so let's understand how this encapsulation will be helping us. So in encapsulation, what usually happens, we are combining two things. The name itself suggests, the name says that you are combining something. Encapsulate, okay, encapsulation. So the packaging of several items together into one unit is called encapsulation. Okay, so in encapsulation, both attributes and behavior of the object are packaged together. Now, in this, the attributes, okay, the values, and the behavior, okay, behavior means the method or the operation or the service. So these two things are combined and are packed together. We call it as a packaged. Okay, they are packed together. The only way to assess an object's attribute is through that object's behavior. Now, if we want to assess, like we want an access to the object's attributes, okay, and we want to change their value, as we say that attributes always represents the data. Okay, so if we want to change that, so that would be through the object's behavior, how object is behaving, how it is interacting with other objects present in that model. So that would decide whether its value can be changed or not. Okay, now, in this, it states that no other object may prefer that others' behavior. Okay, so object cannot depict and means object A cannot tell or cannot define how object B would be behaving, how object B would be interacting. Okay, so it will not tell. Now, have students identify the behavior of a door, window, or a VCR. Okay, so it's an object. Now, how they behave? Okay, they would have their own behavior, they would have their own services. Okay, so these would be an example of behavior and encapsulation. Now, object classes. Now we have studied that a class consists of object. Object is an instance of class. But there is one term which is used in object modeling, that is object classes. Now what is this object classes? So object classes or object class can be defined as set of objects that share common attributes and behavior, sometimes referred to as class. So it is the same thing which we call. But in some cases, it would be referred, instead of calling a class, it would have been denoted as object classes. Now, let's see how these object classes would be represented in UML. In a previous subject in the software engineering, we have already studied about UML and its representation. Okay, so in this subject also we'll be seeing how these UML can be drawn, how does they work. Okay, so it is unified modeling language. So let's see how these object classes are represented in unified modeling uh, language. Okay, how it helps in. So in UML diagram, when we would be talking about the objects, when we would be taking data from object modeling, how it has been processed, how the different objects were interacting with each other. So in that, we'll see that is represented using a rectangle symbol. Okay, so the object rectangle is divided into three portions. Now in UML, usually we use a rectangle to draw an object class, and that would be divided into three portions. Now what are these three portions? The top portion contains the name of the class. Okay, so in the rectangle box, the top would be the name of the class. Now in the middle portion, there would be name of the attributes. If you remember few class back, I have already shown how the class is represented. I have shown it with the bold letters, that is the name of the class is represented with the bold letters, and whether its attributes and what are its operations, public, private. That also I have shown with the symbols plus, minus, and different symbols are used. Okay, so the same thing would be done here. In the middle portion, we would write the names of the attributes. Okay, which would show uh, the lower portion contains the behavior or the methods. What operation would be performed, what would be the method, or what would be the service provided by that particular object. Now, to simplify the appearance of the diagram, see, as we are making these many objects of different classes, so it would be very clumsy. And as all the classes will be interacting with each other, some interaction, some communication, some data flow, some changes would be going on. So how they would be represented? Okay, so or to specify more details about a class symbols can be drawn without methods and attributes. So in some cases, you may see that when we are drawing object classes or diagram or object modeling or UML diagrams. So there would be a simple a rectangle and just the name of that particular class or maybe an object would have been written. Okay, all these attributes and methods and operations may not have been written so that it would become simple and easy. Otherwise, so many details would be involved inside it. So that could be uh, so that would help us to make that diagram look simple and easy to understand. Okay, so simply simplify the appearance of a diagram or to specify more details about a class. Class symbols can be drawn without methods or attributes, or the attributes portion can be expanded to include data types, length, etc. As we know, that attributes have some values, it shows stores some values. So in some cases, those things could be skipped, and in some cases, those attributes can be their means data types can be represented, whether it can store a character or an integer value or a float value, and their size would be depicted, that would be defined there, so that it becomes easy for the developer to work on that project when the diagrams are specified so clearly and neatly. Okay, now the appearance depends on what the author of the diagram is intended to communicate. Okay, so at the end, when we'll be going through that particular diagram and we'll be studying that particular diagram, so we can understand The appearance means that look, that diagram would make us understand and what actually the author of that particular uh, diagram, who has made this diagram, wanted to convey. What was the idea behind making this particular diagram, or what are his intentions actually, what he is looking for. Okay, so that would explain us maybe one of the module of that particular project in which we are working on, and it will make us understand how different things are interacting with each other, because these all models, whichever models we are studying in this subject, these all would help us to understand how things would work in a better way. Okay, so these would be done with the help of a UML representation, or an object model, or the representation symbols which we are using. Now, object or class a relationship, a natural business association that exists between one or more classes and objects. We know that object is an instance of class which has some attributes, values, properties, operations. Okay, so we know the relation between them. So objects and classes do not exist in isolation. The things they represent interact with and impact one another to support the business mission. Okay, so they interact with each other to give us the result, and thus that model works. Okay, like that data in that flow. So an object or class relation is graphically illustrated in UML as connecting lines between two classes. Okay, so how the relation between class and object is represented in UML, connecting lines are being drawn, and thus the relation between the classes and their objects is depicted. Now, this relationship is commonly referred to as an association. Okay, so this relation shows the association between those two classes. Now, the line the line is labeled with a verb phrase that describes the association. So when I was teaching you about the association, I have already told you that on the line, whatever word we would be writing, it would be in the verb form. That is when something is going on. That would show the relation between the classes. Now all associations are implicitly bidirectional. Okay, to and fro would be there, because as both the classes are interacting with each other, meaning that they are interpreted in both the directions. Means in both the direction, the communication, the data flow is going on. Okay, so for example, if we'll be talking about a business model, so in that we would have customer, we would be talking about the order, whether the order was taken or not. Yes, must there exist an instance order for each instance of a customer? If no, what was the next order given? Okay, so those details would be taken in that. Okay, so this is how the relation between object and their classes will be depicted. Now, if we talk about the process involved in object modeling, so in this, modeling the functions of the system, finding and identifying the business objects, and organizing the objects and identifying their relationships. So, these would be the different things how these object model process. Okay, so we can say that modeling the functions of the system. how they would be working, modeling the functions. As we have studied about the functional modeling, we were seeing how functions can be elaborated, how inside that function what all processes are going on, that are all things are represented in that particular diagram. Okay, so that would be done in the same way in this object model. Now in this we would be finding and identifying the business objects. Now what would be the objects related to this particular system environment, how they would be interacting, that would be the next process to do in the object modeling. Now the next would be organizing these objects and identifying this relationship. Okay, to have relation, how they are interacting with each other, how they are related with each other, that will be seen in the object model. Now, organizing the objects and identifying their relationship. Now, how this is done? This is done by identifying the association. Just now we saw association between the two classes is represented by the bidirectional line and it is being written in the form of verb. Okay, so how association, how multiplicity is going on, that we would be seeing. Now identifying the generalization and specialization relationship, identifying aggregation relationship, then prepare a class diagram. Now this class diagram would be the graphical representation of the whole system, object involved in this, how those objects are linked to a particular class, how they are interacting, how they are having relationship between a class or a different class, that would be represented in the class diagram perfectly. Okay, so this would all these all things would be included in object modeling. Now tomorrow we'll be seeing these things in detail, how this association, generalization, specialization, aggregation, these all things in object modeling is represented or depicted, or it is being represented in the uh, pictorial form, graphical form, that all we will be seeing. So this was all about today's class. Okay, so next in the next class we would be seeing how these things would work and how we can draw the object modeling or the class diagrams or the object diagrams in detail. Okay, today I'll be uploading all the notes till date because I have uploaded only two lectures. So from lecture 3 till today, I'll upload all the details, all the notes. If you feel any doubt, you can call me or we can discuss them during the lab lecture. Okay, now I have downloaded the attendance. You can leave the session.
Thank you, ma'am.
Yes.
Ma'am, hello.
Ha, Nirmal?
Ma'am, object diagram and class diagram both are same or different?
There would be slight difference when we would be depicting the attributes and the operations in detail, that would be object diagram, or object is always related to the class diagram. So if in the class diagram we are showing the objects and their behaviors, तो वो class diagram होगा. And if we are only talking about the object models, so there also we need to have classes, but we would not be talking about the classes in detail. We would be talking about the behavior object in detail in the object modeling. So you can say that it is similar, but both would have different roles. How the things are being described, that depends.
Okay, ma'am. Thank you.
Yeah.